Floating hundreds of miles from Earth, astronauts get a unique perspective of our planet. While they might recognize landmarks, space is the only place they can see the very edge of our planet's atmosphere.
From orbit, particularly looking at the horizon, did bring to mind how thin the atmosphere is. It's like an onion skin around this great big ball of the Earth.
This uppermost layer of Earth's atmosphere, the ionosphere, also overlaps with the very beginning of space. It's the job of NASA's new mission GOLD, the Global Scale Observations of the Limon Disk Instrument, to study this region, a region that isn't just for astronauts to explore, but that affects humans every day down on the ground. For one thing, this layer of the upper atmosphere helps protect us from harmful radiation and energy emanating from the sun. But in our modern society, it does so much more. It affects the smartphone that sits in your pocket and the radio waves that guide our airplanes. The ionosphere is a crucial layer of the atmosphere through which our communications and GPS signals travel. And when this region changes, it impacts those communication signals. Changes can occur above this region from the sun's activity, also known as space weather. Changes can also occur below from Earth's weather, such as hurricanes and wind patterns. GOLD connects the dots between how space weather and Earth's weather shape the upper reaches of the atmosphere. But this region isn't easy to study. The ionosphere spans roughly 60 to 400 miles from Earth's surface, which is too high for aircraft and scientific balloons, and the lower regions are too low to easily study with satellites. What are attainable, however, are the swaths of red and green light shining out from the upper atmosphere. Formed when the sun's rays hit atmospheric molecules, this light, named airglow, comes from green and red bands of glowing gas. Some of the airglow is invisible to our eyes, shining in infrared and ultraviolet light, which can only be seen with scientific instrumentation. Taking advantage of our planet's natural glow is GOLD. The GOLD instrument, which is about the size of a mini-fridge, is hitching a ride on a commercial communication satellite, SES-14. The satellite's orbit lies 22,000 miles above Earth, where it can record images in ultraviolet light to monitor changes in airglow across the globe. These images give information on the temperature, density, and composition of particles in the upper atmosphere. GOLD collects these observations faster than any mission has ever done before. It captures an image of Earth's entire disk every 30 minutes, allowing scientists to see how the upper atmosphere evolves throughout the day. GOLD joins a host of missions studying the very nature of space, around Earth, the Sun, and planets. As NASA ventures farther and farther from home, knowing the nature of space itself is crucial for our journey to understand our solar system and beyond.